cutting tools is one of the first things you learn in machining is like, what cutters do I use to remove the material, right?
Yeah.
Because usually you're just throwing a part in a vise and you clamp down the vise and that's it, right? But as you get more advanced, the game becomes, how do I work hold? How do I hold the most amount of material? How do I hold that particular part in the most unique way that I can machine as much surface as I possibly can,
Without
right?
changing it. Yeah.
Yeah, because every time like in a vertical, if every time I pull it out of a work holding vise, dovetail system, whatever you're using, and I flip it, every time I handle it in management is a chance for the part to get scrapped.
Right.
Or be out of tolerance.
Or it takes too much time.
That just take too damn much time, right? But even if you could still way faster than doing it manually on a manual machine,
Right.
right? So then you step up, okay, now we're automated from work hold to work hold to work hold to work hold, right? I'm flip-flopping this thing, but every time, you go from here to here to here to here, I got to blow it off and clean it. And now I'm clamping on a finished surface.
Yeah.
And if somebody misses a little chip in there and you squash a chip into your beautiful surface, scrap, like in our world,
Yeah.
rarely can you recover. In many ways, my team kind of fought me on like, why would we go backwards? Why are we going backwards to a 3-axis machine when you could just shut it? Remember all those years you told us about, putting it in the machine once and machining the whole thing down, net. I'm like, yeah, because that's the only extent that I knew, which was how do we not touch the part?
Yeah.
And let the machine finish the thing completely net, pull it out, inspect it, snap it off, blend, and it's done, right? Fantastic. And that's with all the complexity and all the things we do. However, then you start running out of capacity. Like, it's only 24/7 in a day.
Yeah.
You got maintenance, you got clean, you got all this stuff. It's like, when you start running out of capacity, you got to be like really efficient with your capacity. So do we go and say, hey, we should spend another $2 million on a piece of gear? And so, and in many places like us, we're not totally maxed out because we're going to do a whole series of, swapping out older gear for new gear.
Right.
But what we're doing is refreshing how we look at processing parts in a bigger picture, because you start analyzing things differently. We start analyzing each one of the machines and how productive they are. But what does that mean? What's productivity? Well, we had, a piece of real estate that we could drop a new machine in. Is that the right machine based on our work statement to get the most amount of efficiency, productivity in that little piece of real estate? And then once you do it, then you realize, oh my God, that thing's unreal. Look at the productivity levels. Well, then you now have targets on every other machine because you're like, look how much space that thing's taking up. And it's like 1/4 the productivity.
Yeah.
So you start realizing I should probably analyze every square foot of our facility on how much more productive it can be. Because what my tendency was, because this is what I learned, is you just keep, basically growing your footprint, right? Let's get a bigger building.
Right.
Let's buy more equipment. It's like, yeah, but if your overall total environment spindle productivity or uptime is only like at 25% or 50%, whatever the number is, right? Maybe the gear that I have isn't the best gear for the type of work statement that we have.
Right.
For what we've evolved into. But, you look at a piece of gear and you're like, yeah, but I paid that thing off, and it's a cash cream machine at some level.
Yeah.
So why would I want to, change over? Everybody knows how to run it. They've got all this tooling built for it. Like, it's just easy. And that's fair. But the other side of it is like, we have one footprint of the building. And so the amount of downstream cost of picking everything up and moving into a bigger building is outrageous.
Yeah.
Right? When you can come back and look at your own footprint and say, well, how much more efficient can we be in the same location?
Yeah.
And so you start looking at all the different spindles, and then you start analyzing your work statement. We say, well, we really need that long travel. Then my argument is, but what percentage of our work statement is long travel? Historically is like, we take anything, take all the work.
No.
But you start getting to a certain point and you start to start looking at your, the concept of constraints, right? The theory of constraints. It's like, well, where's our bottleneck?
Yeah.
If you look at overall the big machine, what I'm focused on is what I call beyond the machines.
Right.
How do we go to the next step? How do we scale to the next level, if you will? And historically, it would just be add another spindle, add another spindle, add another spindle, push that one over there, squash those machines all together in a little work cell. But then you start running out of power. Right?
Yeah.
And there's always another constraint.
Right.
And so instead of sort of like thinking in that normal term, which is just go buy another machine, right? What if instead of growing that way, you could grow differently? You can start thinking about, how can I get more efficiency out of one piece of gear? Or is that piece of gear not going to facilitate or not going to add to where a long-term model is? Right. And I recognize these things over, like when we got our first horizontal, just by the mere nature of having that large, more than double the capacity in a tool holder, and that one horizontal, because I had this 4th-axis capability, and it had a pallet swapper on it, just a single, right? So that ability to swap pallets out and get that new work inside the machine back to work, I can show a 16x in productivity by putting that part into that cell. We didn't have a pallet machine before.
Right.
And we didn't have horizontal 4-axis big tool changer. So all of those pieces stacked up, that one single standalone, had a dual pallet on it though, standalone horizontal, would outproduce every one of our verticals combined. It was so outrageous. And we started to force work into that horizontal. That was like work that we had done on verticals forever. And I was like, man, just trust me, guys, put those pellets in that machine, and you start seeing the numbers. It's like, it just blow you away how much more efficient it was. If we invested on the front end in all the extra work holding to hold more material, you load the machine up and go home. And the machine literally runs all night long with nobody here. And then it gets done and it swaps out, right? I mean, we have parts, these big manifolds, really complex, lots of internal, external work that literally will run like 16 to 17 hours straight. So the idea was very simply as I highly encouraged my team to start transitioning work into that horizontal model, and they can start seeing it. And when you start seeing how much faster the productivity was just insane relative to what we used to do, that changed everything. And then once we realized the machine exceeded our expectation on productivity, it's like, well, then how do we even stretch more productivity out of it from an efficiency standpoint? So we're going to play the theory of constraints game, teaching on this first principles type of idea of how a facility can look at the problem, step back, look at it a completely different way, and then approach that overall problem to solve not just the micro efficiency at a single level in one operation on a machine tool, but how do we step back on the early part of the process and downstream of the process and put the efficiencies back in that model in multiple other areas, and you'll see this absolutely accelerated rate of productivity and growth.